The remainder theorem states that if the polynomial p of x is divided by x minus r, then the remainder r is a constant and is equal to p of r. So in notation, we have r equals p of r. Now this means that we simply have to solve for the value of small r here. And once we get the value of small r here, then we simply substitute that small r to the polynomial p of x. Okay, so that will give us p of r. And so whatever the result or the value of p of r here, then that is the remainder of the polynomial divided by another polynomial. Now, for you to better understand this, let's have some examples. Let's have the first one. So find the remainder when x raised to 4 minus x raised to 3 plus 2 is divided by x plus 2. Alright, so there are actually two ways to do this. No? The first one is by using the synthetic division, and another one is by applying the remainder theorem. Okay, so I'll be showing two so that you will have something to compare after this presentation. Alright, so let's have by synthetic division. Okay, so in synthetic division, we simply get the numerical coefficient of this expression. Okay, but there is a missing term here, or terms, and that is the x squared and the x. So this will give us x raised to 4 minus x cubed plus 0x squared plus 0x plus 2. Alright, so this will now complete our polynomials. We have 4, 3, 2, 1. Okay, now this time we're going to identify the numerical coefficient of each term. So to do that, okay, so we have the numerical coefficient of x raised to 4 is 1. The numerical coefficient of negative x raised to 3 is negative 1. For x squared is 0. For x is 0 also, and we have the constant 2, right? And this one is divided by x plus 2. So if we're going to equate x plus 2 to 0, okay, then that will give us x equals negative 2. So we have here the divisor, negative 2. All right. Now, the first thing that we need to do here is to bring down this, okay? So that will give us 1. And then we simply multiply negative 2, okay? We multiply negative 2 and 1, so that will give us negative 2. And negative 1 plus negative 2, okay, so this is addition, that will give us negative 3. Okay, let's change the color. Let's be consistent with the color. We have negative 3. Now this time we're going to multiply negative 3, okay, and negative 2. Okay, so multiply again. So that will give us positive 6. Alright, so 0 plus 6 is simply 6. Okay, and now we are going to multiply 6 here and negative 2 here. So 6 times negative 2, that will give us negative 12. Alright, so 0 plus negative 12, that will give us negative 12. And so this time we're going to multiply 12 here, negative 12, and negative 2 here. So that will give us positive 24. Right? And so 2 plus 24, that will give us 26. So this is the remainder. Okay? If x raised to 4 minus x raised to 3 plus 2 is divided by x plus 2. Alright. Now what about if we're going to use the remainder theorem? Okay? So I mentioned just a while ago that the first thing that you need to do using the remainder theorem is simply get the value of small r. So how do we do that? So x minus r is equal to x plus 2, because x plus 2 here is our divisor. So solving for r, okay, so this will be simply cancelled out. So that will give us negative r equals 2. Or r is simply negative 2. Okay, so we divide both sides by negative 1, 2 over negative 1, that will give us 2, that will give us r equals negative 2. So let's highlight this. So this is our r, small r. Now we're going to substitute this to our p of x, which is this one. Okay, so how do we do that? So p of r is equal to x raised to 4 minus x cubed plus 2. Okay, so substituting the value of r, so p of negative 2, that will give us negative 2 raised to 4 minus negative 2 raised to 3 plus 2. Alright, and we know that negative 2 raised to 4 is simply 16 minus negative 2 raised to 3 is negative 8 plus 2. So simplifying, this will give us 16 plus 8 plus 2. Or that is simply 16 plus 8 is 24 plus 2 is 26. So this is the remainder when x raised to 4 minus x raised to 3 plus 2 is divided by x plus 2. Now, what have you observed with the result? They have the same. Let's have another one. Let's have x raised to 3 minus 2x raised to 2 plus x plus 6 is divided by x minus 2. Alright, so again, let's start with the synthetic division. Okay, so it seems that our polynomial expression here is complete, no? So we have 3, 2, and 1 here as the exponent. So we're going to identify now the numerical coefficient of each term. Okay, so for x cubed, the numerical coefficient is 1. For negative 2x squared, the numerical coefficient is negative 2. And for x is simply 1, and we have the constant 6. And if we're going to equate here, x minus 2 equals to 0, that will give us x equals 2. So we're going to have 2 here as our divisor. Okay, so now we are going to bring down the 1 here. So that will give you 1. Okay, and the 1, okay, 1 times 2 here. Okay, you multiply that this 2 times 1, okay, that will give you, of course, positive 2. Okay, and negative 2 plus 2 is simply 0. And 0, okay, 0 multiplied to 2 here, that will give us 0. So 0 plus 1, or 1 plus 0, is simply 1. Oops, 1. And we're going to multiply 1 here and the 2 here. So 1 times 2, that will give us positive 2. So if we're going to add 6 and 2, that will give us 8. So this is the remainder. Okay? When x raised to 3 minus 2x squared plus x plus 6 is divided by x minus 2. Okay? So this is our remainder. Okay, now let's try to use the remainder theorem. Okay, so again, the first thing that we need to do is to solve for the value of small r. So we have x minus r here is equal to x minus 2. Okay, and solving for r, okay, that will give us negative r equals negative 2. And so if we divide both sides by negative 1, that will give us r equals positive 2. Okay, so this is our small r. Okay, now let's have the let's substitute this to our p of x. So our p of x is simply x cubed minus 2x squared plus x plus 6. And so if we're going to have p of r, or p of 2, okay, so then that will give us 2 cubed minus 2 times 2 squared plus 2 plus 6. Alright, so this will give us 2 cubed is 8 minus 2 raised to 2 is 4, okay, plus 2 plus 6. Alright, so simplifying, this will give us 8 minus 8 plus 2 plus 8. And 8 minus 8 is 0. So 2 plus 8, this is 6. So 8 minus 8 again is 0, plus 2 plus 6, that will give us 8. Okay, so this is our remainder. And what have we noticed? We have the same answer here. Let's have the last example. Find the remainder when x raised to 4 minus 3x cubed plus 4x squared plus 6 is divided by x minus 2. Alright, so let's start with using the synthetic division. Alright, so again, we need to identify the numerical coefficient of this expression. Okay, but there is a missing term here, and that is x. Alright, so let's try to complete first the expression. So we have x raised to 4 minus 3x cubed plus 4x squared plus 0x plus 6. Alright, now our expression is complete. Then we can identify now the numerical coefficient. For x raised to 4, that's 1. For minus 3x cubed, that's negative 3. And we have 4x squared. The numerical coefficient is 4. For 0x is 0. And for 6, that's our constant. And it's divided by, okay, x minus 2. Okay, so we have here, we bring down 1 here. So that will give us, okay, 1. So 1 times 2, we multiply this. Okay, that will give us 2. And 3 plus negative 3 plus 2 is negative 1. And negative 1 times 2, negative 1 times 2, that will give us negative 2. And 4 plus negative 2, that will give us positive 2. And 2 here times 2 here, that will give us 4. And 0 plus 4, that will give us 4. Okay, and we have 4 times 2 here, then that will give us 8. And 6 plus 8, that will give us 14. So this is the remainder. Okay, that's the remainder. Okay, now let's have by using the remainder theorem. Okay, so again, we need to solve for the value of small r, so that will give us x minus r equals x minus 2. Okay, so this will simply be cancelled out. So negative r equals negative 2. So if we divide both sides by negative 1, then that will give us r equals 2. Okay, so this is our small r. Now let's substitute that to our p of x. So our p of x is equal to x raised to 4 minus 3x cubed plus 4x squared plus 6. Right? And if we have p of 2, then that will give us 2 raised to 4 minus 3 times 2 raised to 3 plus, okay, this is 3 plus 4 times 2 raised to 2 plus 6. Okay, so simplifying, that will give us 2 raised to 4 is 16, and we have 2 cubed is 8 times 3 here, that's 24. Right? Again, 2 cubed is 8 times 3 here, that's negative 24. Plus 2 squared is 4 times 4, that is 16. Alright? And plus 6. So simplifying, then we have here 16 minus 24 is negative 8 plus 16, that's positive 8 plus 8, that will give us 16. 8 plus 6 is 14. Okay, so again, we have 16 minus 24 is negative 8 plus 16 here, that's positive 8. And 8 plus 6 here, that will give us 14. Okay, so this is the remainder. Okay, so what have we noticed? We have the same answer.